Good afternoon, everyone. My name is Martha Entwistle, and I'm editor of Security Systems News. Welcome to today's webcast. The name of the webcast is Storage Wars: Never Lose Video Data. Improvements in video surveillance technology are putting unprecedented demands on traditional infrastructure. Experts predict that by 2017, IP video surveillance cameras will generate more than 1,500 petabytes of new data every day. That's more than triple the rate of 2014. Is your storage infrastructure up to the task? Today, we're going to talk about that question. We're going to talk about how to lower costs, reduce risk, and protect critical infrastructure investments. Before I introduce today's presenter, I'd like to introduce Security Systems News Business Development Director, Sarah Flanagan, who's going to say a few words about Pivot3, the sponsor of today's webcast. Sarah?
Thanks, Martha. Pivot3 delivers software-defined virtual storage and server infrastructure in cost-effective solutions that are purpose-built for demanding, data-intensive video surveillance workloads. Pivot3 provides the highest levels of performance, resiliency, and availability, so critical video surveillance data is stored without loss, protected from any failures, and always available when and where it is needed most. With data from more than 1 million cameras protected in 53 countries, Pivot3 delivers enterprise-class video surveillance infrastructure in an easy-to-manage, simple-to-deploy, scale-out appliance model. Pivot3 serves major customers in demanding video environments, including transportation, government, gaming, education, manufacturing, hospitality, and healthcare. And back over to you, Martha.
Okay, Sarah, thank you so much. So now I would like to introduce today's presenter, Brandon Reich. Brandon is Senior Director, Surveillance Solutions for Pivot3. Brandon came to Pivot3 in 2014 from Honeywell Security Group, where he led the product marketing and global strategy functions for the commercial and enterprise technology business units. Prior to Honeywell, Brandon spent 10 years leading a security consulting and engineering firm. So with that, Brandon, I would like to turn it over to you.
Okay, thank you, Martha, and thank you everyone for joining today. As Martha mentioned, my name is Brandon Reich. I'm the Senior Director of Surveillance Solutions here at Pivot3. And we're going to spend a little time talking about what's happening in the world of video surveillance technology, as well as what's happening in the world of IT. As we all know, video surveillance and physical security technology in general really continuing to merge and converge with the world of information technology. So we're going to take a look at what's happening there. We're going to try to keep this as educational as possible today. There's really a lot happening in the world of IT that directly impacts video surveillance, and vice versa. A lot of things happening in the world of video surveillance that is impacting IT. So we're going to talk about some big trends and some new buzzwords, things called software-defined storage and server and recorder virtualization and even client virtualization. We'll explain what all of that means here in the next couple of minutes as we go through this. But before we do, let's first take a look at what's happening in the world of video surveillance. As we all know, the amount of data being generated by IP video systems is really increasing to almost staggering proportions. We're seeing new types of cameras with higher and higher resolution video, new use cases for those cameras, things like body-worn cameras in law enforcement, and of course video analytics and mobile access. And we're seeing the need for longer and longer video retention time. At the same time, we're seeing prices for those cameras and the surrounding technology come down. So for relatively fixed budgets, we're seeing more cameras being deployed, higher resolution. The ultimate impact of that is that the amount of data being generated every single day by IP video systems has almost tripled, actually has more than tripled just in the last 2 years. By next year, by 2017, we're expecting that number to exceed 1,500 petabytes of data every single day, whereas just 2 years ago in 2014, that number was more like 500 petabytes of data. Now, in addition to that, some firms now are saying that roughly 50% of the data that's produced by the Internet of Things, one of the big buzzwords in the IT world today, 50% of that data will come from video surveillance in the year 2020. So we have massive amounts of data being generated, and now we're seeing additional value coming from that data. You know, it used to be that video surveillance was really only used as a tool to catch the bad guy or potentially and maybe questionably deter a crime or a criminal incident of some sort here and there. But now, more and more, it's being used much more as a proactive security tool. It provides all kinds of additional value to other aspects of our organization, and even in things like business continuity and business intelligence in many cases. So now we're generating much more data, and that data is much more important to us. Now we have to stop thinking in the ways that we have all traditionally thought in the past. We have to start thinking about and managing our video surveillance and our physical security systems like business and IT professionals, because these are critical business tools that provide significant business and organizational value to us. And more we're moving away from, you know, what is traditionally known as closed proprietary security systems, maybe stuck in a back closet somewhere, like the picture that you see on the left, and more now bringing that technology into the data center, managing it as a critical and a business critical tool within our organizations. Now this means that we must understand now how failures and when things go wrong that we previously used to accept as relatively normal, how these failures can have major implications to us in our organizations on a daily basis. Suddenly now we can no longer tolerate things like data loss, even a small amount of data loss, like system downtime, or the inability to access either live or recorded video. But believe it or not, we're actually more susceptible to these types of losses than ever before. But this has significant implications within our organizations. These can lead to major financial penalties, to major liabilities, and all kinds of other things that drive up and increase risk and vulnerabilities inside of our organizations every day. Now, believe it or not, the vast majority of video surveillance infrastructure today is not prepared to protect us from these types of vulnerabilities. What most people know as NVRs, or network or video recorders, what we typically refer to as direct attached storage, or DAS, all these terms really used interchangeably, were initially designed to function like VCRs, because that was the model that our industry understood. That was the model that we were the most familiar with. But believe it or not, this architecture is really vastly inferior to more modern server and storage infrastructure solutions, and it's prone to single points of failure, which can directly result in all the things that we just said we can't tolerate anymore: data loss, system downtime, the inability to access both live and recorded video. And for larger systems, direct attached storage solutions can actually perform quite poorly and can lead to some pretty significant inefficiencies. Now, IT departments recognized a lot of these shortfalls of direct attached storage a long time ago. And in fact, they moved away from DAS as a general purpose data center solution really starting in the 1990s. They moved to more of a separate server and shared storage infrastructure, or what's now referred to as a virtualized server and shared storage infrastructure. And this solves a lot of the problems that come with direct attached storage. It solves problems of inefficiencies, of resource utilization. It kind of solves that problem of not being able to access recorded video during any kinds of failures. But the problem with SANs primarily is that they work pretty well for large environments that have lots and lots of money and tons of IT resources that are dedicated to managing these on a day-in, day-out basis. But for most video and physical security systems, this type of solution is really extremely expensive, extremely complex, and highly proprietary. Oftentimes, organizations have teams of dedicated, highly trained, and highly paid people that their sole purpose, their sole job is to manage these large-scale SAN systems on a day-in, day-out basis. And believe it or not, yes.
Oh, excuse me, and I just have a question here, and you can address this now or when, if you want to finish up your thought. Sorry about that. But quick question here. It says, what are the benefits and drawbacks of using NAS for video surveillance instead of SAN? So maybe you want to address that when you finish up your.
Yeah, sure, no problem. In fact, that's a great lead into the last point about SAN, and that is that SAN is really built for general purpose IT applications and really not optimal for video surveillance. What that means is it doesn't perform very well for video surveillance. NAS that Martha just mentioned, or that was brought up in this question, is another type of shared storage solution. NAS actually stands for Network Attached Storage, whereas SAN stands for Storage Area Network. Not critical exactly what the differences are. They're actually very similar in that they both provide pools of shared storage that's accessible by every single video recorder or server out there. But a NAS solution can be lower cost than SAN, however, adds a significant amount of overhead, really not designed for an intensive application like video surveillance, and can lead to extremely poor performance and all kinds of lost video, which I'll explain about here a little more in just a minute. So we generally would never recommend NAS for a video solution. SAN is a much better option, but like I said, comes with the added expense and the added complexities of large-scale enterprise-class systems. So it's a good lead-in, in fact, to what we talk about now. And when we say that these types of solutions are not optimal for video, what does that really mean? Well, to understand that, we need to first understand the concept that video surveillance workload, the video surveillance data, is actually very different than traditional types of data that are out there. The first way that we show that it's different is we point out that traditional IT workloads, these could be things like email systems or web servers or financial systems or databases or whatever the application might be, are what we call read intensive, meaning roughly, general rule of thumb, roughly 80% of the time they're reading data from a disk, and about 20% of the time they're writing data to the disk. And as a result, most server and storage infrastructure is optimized for that 80-20 ratio. Well, video surveillance is actually the exact opposite of that. In fact, we say video surveillance is more like 99% of the time we're writing data to a disk, and a small fraction of the time are we ever actually reading data from that disk. Additionally, video is a very bandwidth and CPU intensive application. Anyone who owns a mobile device knows that getting particularly high definition video is a challenging task to send across a network or across an airwave somewhere. And lastly, video surveillance is a very highly variable workload. And what we mean by that is the amount of data being generated at any one point in time can change very quickly. In fact, the amount of data being generated by a typical IP camera at any point in time. And what you see is that it typically goes along at a relatively low number until something happens. And that something happening could be motion inside of the scene. It could be an alarm event. It could be maybe in a school, it could be a classroom letting out or something like that. Whatever it is, it causes the amount of data being generated by that camera to spike significantly. And now if you imagine that same situation being replicated now across dozens or even hundreds of cameras simultaneously, you can start to understand some of the problem. Typical server and storage infrastructure is designed for some maximum level of data ingest. And what that means is maximum level of throughput, or the ability to take in and capture data at any one point in time. When we exceed that, the result is lost video or dropped video. And people often say to me, well, if I've got a camera generating 30 frames per second, what's the big deal if I lose a few frames here and there? It's actually a very big deal. And I'm going to show you on the next slide why that is. But the implications to you as you're planning your server and storage infrastructure is that your systems must perform very well, and they must be highly resilient to any type of data loss. Performance matters. Performance is critical. When your system doesn't perform well, the result is dropped frames or dropped frames of data. And when frames are dropped, when bits of data are dropped here and there, either one of two things will happen. The first thing is what's demonstrated here on the screen. It's a reduction or degradation in the quality of an image. Now, those images that you see that may look blurry or have a bunch of artifacts on them or what have you, that's intentional. That's not a problem with your screen. That's the way it's supposed to look, because what that's representing is frames that are not being captured adequately and subsequently cause a degradation in the quality of the image. Now you see here, if an end user has invested thousands or hundreds of thousands or even millions of dollars into high definition, high resolution video for the purpose of being able to positively identify what's happening in the scene, and we go back and look at our recorded video, and this is what we see because our server and storage infrastructure wasn't performing properly, they're going to be pretty upset. They're going to look at that and say, we're not getting the return on our investment that we expected. And one of the things that you'll notice is the data that's being dropped, or the area of the image that's being most impacted, is where the most amount of activity occurs. So it's actually the area that's the most important to us. So drop frames are actually a very, very crucial thing for us when it comes to protecting the quality of the image. The second thing that can happen when frames are dropped, and perhaps a more critical thing, is that video can be lost entirely. And the reason that this happens, without going into too much technical detail, if you're familiar with a compression technology called H.264, that's the most common type of compression that's used in the video surveillance world today. Frames of video are actually reliant on one another. And so when we start to drop frames or start to lose frames here and there, it actually causes a domino effect. That domino effect is what causes the image quality problems that I showed you previously. But it can also, if certain frames are lost, can lead to entire segments of video that are just completely lost. The real challenges of this is that we typically don't know when this is happening. We don't know until it's too late, until we go back to review the recorded video. You know, cameras themselves really are not smart devices. We generally get one chance to capture data or video being generated by a camera, and if we don't capture it the first time, we don't get another shot at it. So the performance of the system without dropping frames, without losing data, is very, very critical. Now the second piece that we talked about being critical is resiliency. When we say resiliency, what we mean there is keeping your systems online, maintaining your access to live video, ensuring that your systems are always recording, and ensuring that that previously recorded video data is always protected and always accessible. Now, the IT world has come up with lots of different ways to do this, to provide resiliency. So you'll hear terms like backup, like replication, like snapshots, like high availability, or RAID, or some of these other terminologies that are out there. But the problem is that when we try to utilize some of these types of technologies in the world of video surveillance, they just don't work. Video surveillance, as I mentioned before, is a very unique type of application. They can be very expensive to properly deploy with video surveillance, and in many cases, things like backup and replication, for example, or snapshots, they just don't work for video surveillance. Video is constantly changing. It's a write-intensive application, and the things just don't work. So we have to figure out new, better, and more effective ways of driving resiliency, ensuring our systems are always online, and ensuring that our previously recorded data is always protected. Now, before I go and tell you how Pivot 3 has solved a lot of these problems, I want to help you understand also what's happening in the world of IT, of information technology right now. IT is really, believe it or not, being asked to do many of the same things that the security departments are being asked to do. and that is reduce risk to an organization and lower costs. And to do that, they're turning to new technologies that are really turning into these mega trends. So things like cloud, like mobility, flash, hyperconverged infrastructure, which I'll talk about here in a few more minutes. And ultimately what all of this is leading to is something that's being known increasingly as the software-defined data center. Now, as I go forward in this presentation, I just want to point out that whenever I say software-defined, what that really means is that we are replicating the features and functionality of what is typically been specialized hardware, and we're now providing all of the features and functionality through software instead. And what that does is it significantly lowers costs and complexity required to deliver the value that those traditional proprietary hardware solutions would provide. So if we first take a look at what is the future of the data center. Now, if you walk into virtually any data center today, you see all kinds of different things. Primarily what you're going to walk in is you're going to see racks and racks of boxes with flashing lights on the front of them. And all of these boxes do different things. The vast majority of them are either servers or data storage or SAN storage, like we talked about before. SAN is a shared storage solution. More and more now these application servers are virtualized servers, but the reality is there's still boxes and boxes of servers and storage lined up, oftentimes in big long rows, generating all kinds of heat and consuming all kinds of power. Now, more and more, what's happening is that these servers and the storage are the specialized hardware that's driving them is being replaced now with standard commercial off-the-shelf server hardware that runs very specialized software. And the purpose of this specialized software is to lower the cost, simplify the management, and effectively replicate what was previously being provided by very big, very costly, very expensive hardware solutions. And this now is called hyperconverged infrastructure. This is a big buzzword in the world of IT, and it's becoming very, very common and driving a huge amount of change and disruption in the world of IT. But it's all built on the concept of something called software-defined storage technology. And in fact, you'll see on the right-hand side of the screen here that light blue box that's titled Virtual SAN. That effectively is software-defined storage. I'm not going to go into the technical details of what that is. I'll briefly touch on it a little bit later, but I just want you to understand hyperconverged infrastructure and the fact that it's really replacing huge amounts of very complex, very expensive hardware solutions in a data center. Now, this concept of software-defined storage is incredibly important. In fact, it's becoming extremely disruptive in the world of IT. The storage industry today, just for reference, the storage industry is roughly about a $40 billion a year industry in the United States. And it's dominated by a group of companies that you're probably familiar with. These are big, global, multi-billion-dollar companies that you've probably heard of many times in the past. But you'll notice over the next decade or so what's happening is, and this is, by the way, is put together by an independent research firm that covers the IT industry. You're seeing a significant decline now in the share of traditional storage solutions in the storage world, and it's being overtaken now by this concept of software-defined storage. And what I want to point out, a couple of things I want to point out. One is whether we're talking about on-premise or on-site storage versus in the cloud isn't necessarily critical at this point, but I do want to point out is who's leading this change. You'll see it's not the names of the company that you typically see on the front of these big proprietary hardware machines when you walk inside of the big data centers. You're seeing different types of companies. You're seeing software companies. You're seeing the Googles and the Facebooks of the world that are driving this kind of change. Now, this is really massive disruption. And you need to understand it because it's going to significantly impact how physical security technology is handled in the future. So as we said before, organizations are being pushed now to show better return, better ROI from their security investments. We talked about we can no longer tolerate data loss and downtime because it exposes us to really significant liabilities. And more because particularly video surveillance, since it's such a large and intensive application, is being influenced now and in many cases even owned by the IT departments, our server and storage infrastructure has to comply with the requirements from the IT departments, from the data centers that are out there. So this brings me to Pivot3, who we are and what we do. If you're not familiar with Pivot3, we've been in business since 2002. The heritage of our business, we were founded on the concept of solving a increasingly challenging problem of data storage for IP video surveillance systems. We continue to primarily be a video surveillance solutions company today, although we have also extended our technology and our reach out into other non-security use cases. Things like virtual desktop infrastructure, like backup and disaster recovery, or business continuity as we call it, and even general purpose data center infrastructure. Now, for the purpose of today, I'm just going to touch on our video surveillance solutions, and just so you understand how we solve some of these new and emerging challenges that we're seeing in the industry come along today. We're installed in 53 countries around the world, over 2,000 customers, protecting data from millions of cameras. You'll see virtually every end user industry you'll find our solutions in. In fact, you'll find that some of the largest and most critical video surveillance implementations in the world are deployed on the back of Pivot3 video surveillance infrastructure. However, we are not limited to only large centralized solutions. In fact, we've recently deployed or come out with new solutions that bring this new advanced technology to the smaller and even the medium-sized or distributed video surveillance applications that are out there. Okay, so what is it? Hyperconverged infrastructure, purpose-built for video surveillance. What the heck does that mean? Why do I care about this? Well, I'm going to try to give you a little bit of an overview of what this is and what we do. I'll try not to get into too much technical detail. I'll give you a little bit of background on it. But of course, if there are any questions on this, please feel free to ask them, and we'll try to address them as best we can here. So, hyperconverged infrastructure starts out with, as we mentioned before, standard off-the-shelf x86 server hardware. This is the same type of server hardware that you can buy online, that you can buy through Dell or HP or Lenovo or whoever the company might be. There's nothing special, nothing proprietary about the hardware. Typically, it's deployed in clusters or arrays of anywhere from 3 to 12 appliances, or what we call nodes. So each node would represent one box that you see on the screen there. And each one of those nodes runs some very specialized software. And that software effectively turns this cluster or this array into really a highly specialized data center. So it does a couple of things. First of all, we virtualize all of the servers. In this case, these would be our video management servers, video management software servers. It could be the recorders, it could be the management servers, or whatever other servers associated. It doesn't have to just be video, though. These could also be access control servers. They could be visitor management. They could be effectively any type of server application can be virtualized and run on a smaller number of machines. Secondly, you'll see that orange column there. What that represents is all of the storage resources, all of the hard drives, the caching, and everything else that we'll talk about here in a few minutes, are effectively pooled together through software, logically pooled together, to create one common pool of shared storage that we call a virtual SAN. And that virtual SAN is now accessible by every single camera and every single virtual machine or virtual server, regardless of which physical machine they're associated with. So we're creating a SAN, we're creating an enterprise class SAN using nothing but the storage resources of standard off-the-shelf servers. We also, so far we've been talking about the server and storage infrastructure. We also have solutions to virtualize the client side of this, and I'll talk a little bit more about what that means here in a few minutes. But the overall benefits, what we bring to the table here with these solutions, extremely high performance, purpose-built for this write-intensive video surveillance. What that means is we never drop frames, we never lose data, even if we're operating in what we call a degraded mode, when something goes bad, like a piece of hardware fails, for example. We provide extremely high levels of resiliency. So we eliminate all of those things that we said before we could not tolerate. We eliminate downtime, we eliminate data loss, and we ensure that both live and recorded video is always available and always accessible. We scale, we allow you to start small as even 12 terabytes or so, and scale up to multiple petabytes of storage and the related compute capacity to go with that. And because of our virtual client infrastructure, we can enable you to mobilize your entire fully functional integrated security suite and access it from any device. And I'm going to show you what that means here in just a minute. But perhaps most importantly, we can deliver all of this enterprise class infrastructure, all of this enterprise class value in a very simple, easy to use package that does not require any type of advanced IT skills or specialized, highly trained people to run them. So I want to talk, just jump into each one of these benefits and show you a little bit more detail on it. Like I said, I'll try not to get too technical here, but I'll point out some of the highlights and show you how we deliver some of this value, and then we'll wrap up for the day.
Hey, Brandon.
Yes.
We have a question here before you move on. The question is, what is the difference between Pivot3 failover and failover provided by a VMS software?
Sure. Okay, so when we talk about failover, as you'll see when we get to the slide on resiliency, you'll see that we have the failover capability built into our systems. In fact, I'm going to jump ahead real quickly here, and then I'll come back in just a minute and talk about performance. But one of the ways that we deliver this extremely high level of resiliency is we have built-in server failover. What that means is if one of the hardware boxes, one of the nodes, one of those orange boxes you see on the left-hand side there, if it were to fail completely and just go offline, we automatically move the virtual servers to another machine and restart them somewhere else inside of a cluster and ensure that your live video is always accessible and that you're always recording. Now, a lot of people will say, well, that's the same thing that software or VMS failover can do, and that's true to an extent. And I'll tell you some of the key differences. First of all, with software failover, a VMS failover, it will recognize when a failure occurs and restart somewhere else on another box. However, all of the previously recorded video associated with that box that fails is generally not accessible. Okay, it's generally inaccessible, and potentially, if we can't repair the initial box, it could be lost entirely. With the Pivot3 failover, it is always accessible, even if in a failure scenario, if we have to fail over to another box, all of the previously recorded video on that box that failed is actually immediately accessible and immediately available, so we never lose that data. Secondly is for a VMS or a software failover, you generally require some extra redundant hardware sitting out there somewhere, just kind of waiting, sitting out there almost idle and waiting for something bad to happen, which is a pretty inefficient use of purchased hardware. In our solutions, that's not true. Any of the spare capacity that we reserve in our system is always being utilized inside of the cluster, so it's always being put to work. It always adds to the capacity and the performance of the overall system. And lastly, and maybe most importantly, the differences are that with VMS or software failover, you typically have to buy additional software, additional licensing. There can be some manual user intervention required. With our solution, everything is included. That's a base part of what we provide. There's no additional cost for it, and there's no user intervention required when it comes to driving failover. So, since we're here talking about resiliency, we talk about the built-in server failover, but we also have to be concerned about protecting previously recorded video. And if you're familiar with the term RAID, most server and storage systems today use a technology called RAID. And without going into the technical details, what that means is RAID will protect data against the failure of either one or two hard drives simultaneously. So if a hard drive fails, if you have RAID implemented, then you don't lose that data. You may not be able to access it until it's been rebuilt, but you don't lose the data. We don't use RAID in our solutions. We actually think RAID is a bit of an aging technology and doesn't work very well, particularly in larger systems with large-scale hard drives and getting really challenging to manage RAID nowadays. We use a more modern technology called erasure coding, and you don't need to know what the details of erasure coding are other than the fact that we will protect data against up to 5 drives failing simultaneously, or we'll protect data against the loss of an entire node, and there can be up to 16 hard drives in each node, plus 2 additional drives somewhere else in the cluster. If all of those things fail simultaneously, not only is the data protected and not lost, but it is still immediately accessible. Immediately. We go through a rebuild process, but we don't have to wait for a rebuild process in order to access our data. So if one of these boxes for some reason fails, if you just pull the power cord out and the thing just completely goes offline, the servers will automatically fail over, and all of the data associated with that box will remain protected and available. We eliminate any single points of failure, and we drive what the IT world would call 6 nines of availability, or 99.9999% uptime and availability. Very high levels of resiliency and fault tolerance there. From a performance standpoint, we talk about being optimized for video surveillance so that we never lose data. There's a couple of ways that we do that, and I know the image on the right is a little bit technical and you don't need to understand all the details of it, but I want to point out a couple of things. First and foremost, we use solid-state memory and hard drive solutions for write caching. And what that means is this write cache effectively catches the video as it comes in. Solid-state solutions are much, much faster than traditional mechanical hard drives. They're also much more expensive than traditional mechanical hard drives. So we don't use them as a primary storage medium, but we do use them as a write cache, so we can capture these spikes of data as they're coming in. Secondly, we aggregate all of the storage, the cache, and the bandwidth resources from all of these boxes together, and we ensure that they all work together in harmony effectively to manage this very intensive video surveillance application. And then we use something called direct path, and if you're not familiar with a virtualized server environment, what direct path is it effectively enables a video management recorder, to be installed inside of a virtualized environment without impacting the performance of that. Most video management software providers will recommend that you not install recorders in a virtualized environment. Because of this problem, we have solved that problem and enabled these solutions now to be delivered in a virtualized environment. Scalability, it's very important, particularly in video surveillance, that we enable our systems to scale up or what we call scale out very efficiently and very effectively. When anything changes in video, whether we're adding cameras or we're changing resolutions or frame rates or whatever it happens to be, anything changes, we have to be able to scale not only storage capacity, but also what's called throughput capacity. And throughput capacity is a function of how much compute power we have and how much bandwidth is available. Now, if you notice the red line on the right-hand side of the screen there, virtually all server and storage infrastructure scales only in one dimension, meaning we can scale storage capacity, but we really don't increase the amount of available video throughput. Because of our architecture and the way that we work, the addition of a single node, just a single box with our software on it, adds both storage capacity as well as compute and bandwidth capacity, which increases the overall video throughput that is available and accessible by every single camera and every single video management server out there. So we scale very efficiently. We scale in a way that's non-disruptive, meaning we're always online, everything's automatically load balanced, and we can scale effectively to unlimited size, to multiple petabytes of storage capacity. Before I wrap up here, I want to touch on the mobility concept real quickly. I introduced this very briefly earlier, but I want to talk about this for just a second. So we have a relatively new solution to the marketplace called the Virtual Security Server. On the right-hand side of the screen, it's up in the top half of this. And what it effectively does is it enables us to virtualize our client desktops. And basically, all of the functions and the environment that you would typically see deployed inside of a security operation or a monitoring center can be virtualized and now delivered out to an endpoint device, whether that is a mobile device like an iPhone or an iPad, or a workstation or a video wall. It could even be delivered to something like a first responder or a remote guard shack, or even something like a chief security officer's home. We can deliver a fully functional, rich client environment with no limited functionality in a secure manner, in a bandwidth efficient manner, to any device anywhere. Now, if you're familiar at all with IT, you may be familiar with a term called virtual desktop infrastructure. That is effectively what this is. This is virtual desktop infrastructure. It's becoming very common in the world of IT as a way to reduce costs and deliver desktop environments now out to any type of device. However, virtual desktop infrastructure does not work well or even at all with video surveillance. And in fact, you get typically about 1 or 2 streams worth of high-definition video is enough to bring a virtual desktop solution to its knees. We have solved that problem. We can deliver now as much as 40 simultaneous high-definition 30 frame per second video streams out over a network in a secure fashion to any device, anywhere, anytime. Now remember, this is not just video. Video is the hardest part of this, but we can deliver now fully integrated systems, whether that means multiple different video management systems, if you have more than one client from a different manufacturer, for example, or an integrated access control or visitor management solution, whatever it happens to be. If you can run it inside of your security operations center, we can deliver it in a secure fashion out to a mobile device. And the last thing I'll touch on here, everything that I've talked about so far, your heads are probably spinning. You're probably saying, gosh, this is incredibly, it's great value, but it's incredibly complex. I don't think I'd ever be able to manage it. I don't think I'd ever be able to deploy it. Well, the reality is that we have designed all of the complexity out of delivering this enterprise class infrastructure. We have made our solutions extremely easy to deploy and extremely easy to manage on a day-to-day basis. We have effectively automated the vast majority of all of the management features and functionality that are required, and we enable you to manage all of this in a very simple single pane of glass application that we provide. It's very point and click, very easy to use and understand, does not require advanced IT skills, requires a person with relatively moderate computer skills to manage on a very part-time basis. If you are in an environment where the end user IT department prefers to use their typical management tools, many of them use a tool called vCenter from VMware to manage their server and storage infrastructure, we can work just fine in that environment as well. We can plug directly into a vCenter environment, but we don't have to. So we're very flexible in terms of how simple we are to deploy and to manage. Okay, just to sum all this up, I won't go back through all of the list of features and functionality that we provide on the left-hand side. I just want to point out our solutions have been specifically designed and built for video surveillance, for critical video surveillance implementations. The benefits that we provide are preventing video loss, preventing data loss, maximizing uptime and availability, scaling from very small or distributed environments to very large, complex environments very effectively and efficiently and cost effectively as well, and reducing cost and overall complexity of these systems. The one last thing I just want to point out before I wrap up here is we have deep domain expertise in the world of video surveillance. We've been doing this for a long time. Now, we've been in business technically since 2002, but our company, our organization, is made up of people that collectively have hundreds of years of experience in the world of video surveillance, and not just in server and storage infrastructure, although that's where our solutions expertise is. We understand at a very deep level the entire ecosystem and all of the different pieces and parts that go into it, and we can help you plan, design, and implement solutions that make the most sense, not only from a server and storage standpoint, but across the entire spectrum of the solution. So I thank you very much for your time today. I think we have a few more minutes left here for some additional Q&A if we have any, but if there are any other questions that come up after this this session is over, we'd be happy to continue this discussion down the road if necessary.
So thank you, Brennan. Great information. We do have a couple questions here for you. The first one is about, let me see, says, how do you maintain the judiciary evidence trail? Okay,
so I assume that we're referring to a law enforcement environment. The CJIS, the Criminal Justice Information System, has come out with a number of requirements on how we store and protect video data. I assume that that's what this question is referring to. We do comply with CJIS requirements. We do that through an integration with another third-party solution called Com Software. We have a direct integration with them and a partnership with them that enables CJIS compliance as well as a number of other regulatory body compliance with various regulatory requirements out there as well. So we achieve very high levels of compliance as necessary, depending on the particular end user situation.
Okay. All right, that sounds good. There's another question here about SSD. SSD has a lifetime write limit. How often do you have to replace those SSDs?
Oh, that's a good question. Yeah, okay, we have an educated audience. You're right. SSD, if you're not familiar, it stands for solid state drive. That's that flash-based hard drive that we use in there primarily for write caching. You're correct in that solid state drives do have a limitation on the overall life. We use a technology called MLC SSD, and what we actually do is each one of our boxes, each one of the nodes will have 800 gigabytes of MLC solid state hard drive inside of it. But what we do is we only utilize 50 gigabytes of that cache on each one of the boxes at any one point in time. Now that's all aggregated across the entire pool. However, we only utilize 50 gigabytes at any one point in time, and then what we do is we actually write to different segments or different sectors of the solid state drives over time so that we don't so that we effectively extend the lifetime of those drives. And what you'll find is we extend that life to the point that we typically exceed the usable life of the mechanical hard drives that are in there. So we get all the benefits of the solid state drive and the speed and everything that we do, but we don't effectively burn them out too quickly.
All right. Okay, thanks. Another question here. It says, most VMS companies recommend that the servers should not be virtualized. How do you overcome these limitations?
Yeah, that's a good question. So I was referring to this a little bit earlier on the performance slide that I was talking about. Typically, when you virtualize a video or any application for that matter, but particularly video management, all that data has to be what we call has to be written through a piece of software called the hypervisor. The hypervisor, what that is that's a tool that typically comes from someone like VMware that enables all of this server virtualization. Well, that process of writing data through the hypervisor can impose anywhere from a 30 to 40% performance decrease, write performance decrease, because what happens is the data comes from the video management software, goes to the hypervisor, and then the hypervisor controls the process of writing it to disk. Our software, by the way, is called vStack. It stands for Virtual Storage and Compute. It actually becomes the operating system on the box. It also becomes effectively the storage controller on the box, and I say effectively. One of the things that it does is it enables the video management application to bypass, or actually it enables the virtual server, which houses the video management application, to bypass the hypervisor on all of these write transactions and write directly to disk, as if it were installed directly on a bare metal box, just as in a typical direct attached storage environment. So we eliminate that 30 to 40% performance tax that's typically found in a virtualized environment. And we do it in such a way that we do not prevent any other of the VMware tools, things like vMotion and high availability and fault tolerance, some of these things that VMware provides. We don't prevent any of them from working. So we enable you to bypass the hypervisor and to still utilize all those great tools from VMware and not realize any type of performance task, any type of performance slowdown. So that's how we get past the virtualization challenge.
Okay, great. Another question here. It says, how well does this work, and what would be general suggestions for an enterprise system monitoring several remote buildings? Would this work as a central storage device, and if so, would local storage still be recommended? The answer to that is typically yes, but it depends. And whoever asked the question, I'll follow up with you directly, and we can talk about your particular situation. Typically, in a distributed environment like this, the biggest limitation to centralizing your server and storage applications is the network. So we like to understand what kind of network infrastructure is in place, what type of bandwidth is available, how robust is that network, et cetera, et cetera. We have in many cases, deployed solutions in distributed environments, for example, like a school system, a K-12 school system that's got 20 or 30 separate buildings across a city somewhere that's streaming all of their cameras back over a pretty robust network back to a centralized storage environment. It works great for that. And in fact, the virtual security server that we can plug in to that centralized environment can then turn around and deliver the clients back out to those remote sites in a very, very effective and very efficient manner. That's a great solution. But it typically depends on the network environment. If the network is not capable of bringing all those cameras back, then we have smaller solutions, something that we call the Edge Protect that we've just released, that that really deliver all the same value, but are developed specifically for these distributed environments. So we can deliver, all this value in a much more cost-effective manner for the smaller implementations. So we have solutions that work in either way, but it would typically depend on what the network looks like. Okay. Another question. The slowest component in video systems is hard disk drives. How do you deal with disk fragmentation, slow I/O?
Yeah, okay, good question. A couple of ways. First of all, first thing is we utilize the solid-state cache that I told you about. That manages all of the initial ingest. So we capture all of the data as it's coming in really high-speed solid-state drives, and then we turn around and we dump that data to disk as the disks become available. Secondly, is we don't use file-based storage. We use block-based storage. So that in SAN, in fact, when I was talking about NAS earlier, NAS uses file-based storage, as does any type of DAS type solution, which can lead to this file fragmentation that you talk about. We don't use that. We use block-based storage, which is not prone to fragmentation challenges, like you talked about before. And then thirdly, the fact that we don't use RAID, we use a technology called erasure coding. What that means is we can actually take every single piece of data that comes in, we can break it up and distribute it across every single hard drive, or what we call every single spindle inside of the entire cluster, regardless of where it is. Now, when you're talking about write-intensive ingest or high-throughput ingest, what's most important is not necessarily the speed of the drive, or particularly not the rotational speed of the drive, but it's how many spindles do you have available for every single write process or every single write transaction. We can distribute every single write transaction across up to 144 drives inside of a cluster, okay, and use all 144 drives in parallel simultaneously. Now, our software manages that process, but what it means, it's very, very optimized for this write transaction process. And the last thing I'll talk about is, again, back to our patented erasure coding technology. It's called scalar erasure coding. When things go bad, like a drive fails, or multiple drives fail, or a node fails, or whatever, what have you, the way that our architecture works is we effectively limit the impact that that failed drive or that failed component has on the overall performance of the system. So typically in a RAID-based environment, when a drive fails, you're going to see a significant slowdown in the overall performance of the system and how fast it can process write transactions. We don't have that slowdown. Our system is extremely efficient in the way that we continue to manage the writes and the way that we rebuild any type of failed component. And so we won't, even in these degraded modes, we won't suffer slowdowns.
All right, Brandon, I'm afraid we've run out of time. We have a couple questions that we didn't have time to get to, but I will forward those to you so that you can contact the questioners directly and answer their questions. And I wanted to let everyone know that everyone who signed up for today's webcast will receive a link to the recording. You should receive that link within 24 hours. The webcast can also be accessed at Security Systems News website. That's www.securitysystemsnews.com. And the link will be live this afternoon and available for the next 3 months. I'd like to thank Brandon Reich of Pivot3 for a terrific presentation, and thank Pivot3 for sponsoring today's webcast. I'm Martha Entwistle, editor of Security Systems News, and we'll hope everyone has a great afternoon. Thanks, Brandon.
Okay, thank you.